Section 3. Creating the mouse user interface. The mouse user interface is responsible for the user's interaction with the various objects in the scene, either being standalone objects or components of an instrument. Depending on the object, a particular interaction with it is allowed. The first sorting out of interactions is done in Mouse UI monobehavior script. Mouse UI, along with Ego Controller, are the most important scripts in our Virtual Lab implementation. However, unlike Ego Controller, which is attached only to Ego game object, Mouse UI is attached to any game object in the scene that is interactable by the user through the mouse. Section 3.1. The mouse cursor. The cursor in our implementation differs from a typical cursor for two reasons. First, it does not have just one shape. It rather takes several different forms depending on the allowed actions on the interactable lab object that it is hovering over. Second, it is locked in the center of the screen, or more precisely, in the center of our camera's viewport. In the following sections, we shall explain both of those traits in detail. Section 3.1.1. Cursor's different forms. The game's cursor comes in various forms, each one corresponding to particular permitted actions on objects. In total, we have 6 different cursors. Wedge cursor, which is the default cursor, hand cursor, grab cursor, finger cursor, pressing finger cursor, and eye cursor. Having stored the PNG files corresponding to our cursors in the /assets/resources folder, in the inspector we set their texture type to be cursor. So we select all the cursor PNGs, and here in the texture type we choose cursor and we press apply. We define default cursor as our wedge cursor in Edit, Project Settings, Player. In the default cursor, we press Select, and in the box we type wedge, and we choose wedge as our default cursor. Before we explain how the various cursors are used, we will go through their declaration as texture 2Ds and their initializations in the Mouse UI script. For convenience, we first create a game cursor abstract class in the Mouse UI script containing a texture 2D attribute for the cursor shape and a vector 2D attribute for its offset from the object that we would be hovering over each time, as well as a trivial initialization function. Then, in the mouse monobehavior class, we define several global static variables. Obviously, the texture 2D variables will be used to load the PNG images of the different cursors from the /assets/resources folder, while the integer ones will serve as their numerical identifiers, with current cursor storing each time the identifier of the cursor which is active. Furthermore, a global static list of instances of the game cursor class created by us will be used to bundle each cursor with its corresponding shape and offset vector. It goes without saying that all of the aforementioned elements are static, so as to be applied to all interactable objects which have mouseui.cs as their script component. The respective initializations are done in MouseUI start function like that. We also define a static function switch cursor in MouseUI for changing the cursor each time. This function takes as argument the current cursor's numerical ID, and according to that, it sets the cursor through Unity's embedded function cursor set cursor using the respective shape and offset as defined in Start. Section 3.1.2 Cursor's locked position. As already mentioned, the mouse cursor in our UI must be locked in the center of the screen. When we rotate the mouse horizontally or vertically, we want the rotation of Ego's game object or its embedded camera respectively to be changed, but the cursor to remain in our camera's viewport center. The practical reason for this is that we would not want our mouse cursor to divert from Ego when the latter or its camera is being rotated. That is achieved by using the setCursorPose function from user32.dll file. Thus, we first import setCursorPose function in EgoController MonoBehavior class from user32.dll file. Next, in EgoController's update function, we add the line setCursorPose with arguments the half of the width and the half of the height of the screen. This way, we achieve that our cursor is constantly locked in the center of the screen. However, keeping the game's actual cursor locked in the center of the screen results into the cursor's flickering when rotation takes place, due to the delayed execution of the EgoController's update function with respect to the movement of the mouse. So, let's test our code by pressing the play button. We see that the cursor is indeed locked in the center of the screen. However, we also see that the cursor is flickering. A workaround for this problem is to hide the real cursor and use a locked 2D texture with a fake cursor in its place. The hiding of the real cursor is done by the cursor visible equals false command in the start function of EgoController. Now, in order to depict the fake cursor, we define the onGUI unity function in EgoController script, which calls a static function :GUI in MouseUI script, also defined by us. As for MouseUI's :GUI, it calls another static function of MouseUI called displayFakeCursor, which draws a 2D texture with the shape of our current active cursor in the center of the screen, taking into account the cursor's offset. For our code to run and the fake cursor to appear, we need to attach MouseUI script to at least one game object in the scene. We therefore select slide game object and we attach MouseUI to it. But since we hide the real cursor and draw a fake cursor in its place, one might wonder, why bothering resetting the real cursor through Unity's cursor.setCursor function in our switch cursor function and repositioning it at every time frame in the center of the screen? Well, although we have hidden the real cursor and display the fake cursor in its place, the cursors hovering over objects and controlling the user's interaction with them is still the real one. The fake cursor is used simply for user-friendliness purposes since it does not flicker. Moreover, as we shall see in later sections, there are cases where the fake cursor is being hidden while the real cursor becomes visible and unlocked from the center of the screen, therefore being an indispensable part of our user interface. One might also ask why onGUI function is not in MouseUI script instead of it being in EgoController script and indirectly calling static functions in MouseUI. The answer to this is that onGUI is not a static function, but we want it to behave like one. MouseUI, as already mentioned, and as we shall see in detail in the next section, is attached as a script component to a great number of game objects, not just one game object like EcoController, which means that if on GUI were inside mouse UI, it would be called as many times as the number of game objects that the latter is attached to, resulting that way into poor rendering performance. It is of highest importance to mention that this dual cursor implementation works properly only in builds running in full screen mode. In any other case, the two cursors, the real and the fake one that is, do not coincide. That is the reason that we have chosen the value full screen window for the full screen mode property in the project settings. So now let's test our code for the build that we have created. We rotate Ego horizontally and vertically, and we see that the cursor is not flickering because this is the fake cursor which is glued on the screen center, while the real cursor is hidden. So our code works fine. Yet, while developing the simulation in Unity Editor, which obviously does not render the scene in full screen mode, we need our cursor to occupy the correct position in the screen. Therefore, our fake cursor is useless in this case. On top of that, in Unity Editor mode, the real cursor is not possible to be hidden, since Unity overrides the hiding and shows the cursor regardless. Now, let's press play in Unity Editor to see how our code really works. So, we see that we have two cursors, the real one and the fake one, which do not coincide. And the real cursor is also flickering. Thus, in the in-Unity development stage, we inevitably make use of the real cursor, tolerating the annoying flickering of it. For this purpose, we first modify EcoController start function so that the cursor is hidden only when not in Unity Editor mode. We also modify MouseUI's :GUI static function so that it allows the fake cursor to be displayed only when not in Unity Editor mode. What we actually did was to instruct our system to show the fake cursor only when in build mode. Nevertheless, when developing the application in Unity Editor, we need to run it in the editor countless times, which requires pressing the play and stop buttons interchangeably. When in run mode, the real cursor is fixed in the center of the screen, making it impossible to move the mouse towards the pause or stop button in order to press it and freeze or end the running of the simulation. We can only stop the game by pressing Ctrl P. We therefore want in Unity Editor to be able to unlock and relock the cursor from the center of the screen at will with the press of a button, say the spacebar. Thus, we make use of a global static Boolean variable in EcoController called cursorFrozen initializes true in the start function. Then, in EcoController's update function, we set cursorFrozen's value to be toggled from true to false and vice versa by the press of the spacebar. And if its value is true, we lock the cursor in the center of the screen. Finally, we modify MouseUI's :GUI static function again, so that it now displays the fake cursor only when not in Unity Editor mode and only when the cursor is not frozen.